Hello, Seth. I think we cannot hear you. I don't know if you can open your mic.
Okay, it should be good now.
Yes, thank you.
Sorry about that. So I was saying that the problem is that we haven't put the good canister ID. So I will check the canister ID for the invoice canister. It's this one. Let me see. It's this one. And so we actually need to put it here. And redeploy. One thing to keep in mind is that you can only call canisters on the same network. So if you are doing something locally, don't try to call a canister on the internet computer. If you are doing something on the internet computer, don't try to call a canister that you've deployed locally. Okay. Well, actually, I already have the interface. So this one and this one. If I try to call get password without even calling the invoice canister first, I get this message. Basically, the password canister is going to call the invoice canister and create an invoice for me and return the invoice ID. I would need to pay it to get the password. So if I try to get the password without paying it, of course, your invoice has not been paid. And I need to go to the other canister and pay it. So with the invoice ID as a parameter, so 0 here, it's paid. And now I should get the password. And this is our password. So there are, is there any question on how we define this, like the syntax of defining a canister, having the interface here? Yeah, is there any question?
The canister ID, this changes every time we deploy the canister.
So the question is the canister ID going to change every time we deploy? So no, it shouldn't. Like we have the same canisters ID that we've done, even though we've deployed twice. On mainnet, it would never change. Like if you have a canister, an application, and you just keep deploying, it would not change forever. But the playground is a bit special because after 20 minutes, we are deleted. So that would change. You would have to change, yeah, the canister IDs. That's a bit annoying, but that's also why the playground is free. Okay. So as you can see, it's taking more time when we have like, in this case, it was fast, but I don't know if you remember when I called it for the first time, it was pretty slow. This one is fast, but it was pretty slow because we had to do one intercanister call. And essentially, intercanister calls can quickly get slow. So it depends on which subnet the canister is on. So remember, we have this concept of subnets. And you can call any canister from any subnet, like you can compose applications. But when a canister is on another subnet, you have a bit more delay, so like around 3 to 4 seconds. If the canister is on the same subnet, it's very, very fast. Like it's just like coding basically your canister. It's the same because it's the same environments. So yeah. And so that's why usually bigger applications, they have their canisters in the same subnet. And if they have, yeah, they will have at some points multiple subnets, and they need to take that into account when you build a large application. Okay, so that's about it for the intercanister call, at least for something locally. And we can actually leverage what we've seen today to call any canister on the internet computer, which is pretty cool. I think that enables like to do fun things. So let's say, for example, I want to call one canister. So so this is a canister for the bootcamp dashboard. We can get the IDs. for the backend. And we can go here, put the ID, and find the interface. So we have all those methods that we could call. On the dashboard, you will see the interface in all languages that we support. So you will see the Candid interface, of course, but you will also see a Motoko, like Motoko binding of the interface. So this is converted to Motoko, but also Rust, also JavaScript, also TypeScript. So you can call this canister from any canister languages. If I have a Rust canister, I can call a Motoko canister. There is no problem. And so, for example, for the Bootcamp canister, we could go here, and we can see we have the interface here. So this is all the methods that I've defined on my canister. And we could try to call them, like we could try to submit a project, we could try to remove team, make announcements. We could try many things. So this is like one cool thing about building on the IC. I think it's this like open network where you can compose services one with the other. Of course, it's a new paradigm on how we build things. So it takes time to like put that into practices. But a good example would be like if you have tokens and they follow a certain standard, it would be very easy to do like a registry canister that would essentially list all the tokens with certain standards. And you would be able to do like aggregation of data, would be able to do wrapper to any kind of standard. Like you could imagine many things. Yep. And so if I wanted to call my canister, I would essentially just copy the interface. So I would define it here. Let's Bootcamp canister is an actor. I would need the canister ID. And the type would be this one. So of course, the canister ID is here, here. And then we don't have we don't have all those types defined in our code. So this is not, the compiler is not gonna like it. We have too many new types, but you could actually copy all the types. So you could copy them in your Motoko file, or you can even create another file to store that. Yeah, that would be how you do it. The good thing is actually we don't have to list all the methods because we only need the interface that we are going to call. So imagine I just want to call one method, like for example, get stats. I don't care about the others for this application. And so we would only need this one. So that would make things simpler. We can just, where is the get stats? Yep, here. We would need to define the stats here. What we're doing is not super like smart because we are just calling a function like from another canister. So it's just gonna add more latency and not like do anything. But you could imagine that you could actually do things like if we wanted to have the stats, we would get them and then we could do some kind of operation on it. So yeah, in this case, we're just calling and then returning. So, and this one is the secret canister. So you can see it takes some time. So probably this canister is on another subnet than the Bootcamp canister. And we have the stats. So we have 24 graduates, 115 students, and 182 projects. And so that could be, for example, imagine that my canister exposed the identity of like the principal of all the students in the bootcamp. If I do that, then someone could call that and could, I don't know, airdrop tokens to all students, create an application that only students could join, like all sorts of possibilities. And I think it's like one thing I'm really excited about the IC is this like possibility of just building on top of each other. Yeah.
If I call, for example, the add member function in your canister, and I add a member, I am adding a member in your database.
So yeah, what about the admin functions? Of course, this is just a, so sorry. The question that we had here was, what if I call some of your admin function? What if I try to add members to your canister? And this is a good question, but you can of course block, like you can access, you can create like an access system. So only some principal are able to call some method. I can actually show you like maybe in the bootcamp code. So main.demo. For example, there is a functionality which I haven't used yet, but there is a possibility to make an announcement for the whole bootcamp, like on the dashboard. And it's only possible if you are an admin. So I have this assert, admin is admin. And if you try to call that, we would get an error. So we can actually try. Let's see. So we need to go back to our interface. Where was it? Here. Make announcements. No, it's a simple interface as well, so it's cool. Just a text. Let's say test. Sync. So and then we will return. This will call this function from my canister, which is like doing some add activity and announcements, but it's doing a check that the caller is an admin. And I haven't added this canister as an admin. So if we do it, we will see the assert failure. And so it's going to trap. We haven't talked too much about trap. No, it's not a good one. Wait, I need to reload. Secrets, why can't we see the test? Maybe. Okay. I think I didn't upgrade my canister for some reason. Maybe okay. So here, test. And you can see, actually, I'm sorry for the persons that are online because I think you can't see my screen. Yep, that should be good now. You can see canister. So this is the ID of the bootcamp canister, trapped, assertion failed, and we can even see the line that failed. So line 6 to 5, that's this one. So a trap, we haven't talked about it actually, but it's very different from result error. We have this result that we've been using, OK and error. So this is normal, like essentially the canister returns a value. A trap, the canister doesn't even return a value. So it's actually going to stop the execution of this method. And it's getting out of the execution environment and it's trapping. Interesting fact that I can add about trap is that, and maybe for that I need a simpler example. So I will talk about this counter. So the counter is a very simple counter. We have a value and we increment the value. The simplest way to trap is to assert false. So this is essentially what I'm doing in the admin. But in this case, it's going to trap every time we execute this function. And so I actually need to yeah, we need to add this canister. So counter. So main memory. Not sure what's happening here. Sometimes. Yeah, okay. So we have our counter. And notice that we increment the value and then we trap. Actually, let me, I should have done that before. So what do you think is going to be the value after we call increment and then we call get? So if we look like normally, I mean, we are going to increment the value, then we trap, so we quit, and then we get, so we should get 1. I mean, we are here, this line is executed. So let's try. So we trap, and then we expect 1. But of course, it's 0. So when you trap in a message, the state of the canister is rolled back to essentially before the message was even considered executed. So before even the execution of the function. And that brings me to an interesting point about intercanister call. We can have a concept of commit points, and I will show you. So let me see. Okay, so I need to. So we are going to call the bootcamp canister again to get stats. That's so this time I will increment my counter, then I will try to get the stats, then I will trap, and then we just need this to make sure that the return type is correct. So don't don't try to bother why we are calling this canister. I don't have a good example, like doesn't make sense, but it's just to show you what happens in case we are using intercanister call. So this time you will see that something fun happens. So we call increments, we should trap. We trap on line 17, so that's here. And then we should get 0 because we roll back, but we actually get 1. So what's happening? So when you have an await, when you call another canister, this is what's called a commit point. So here, it's a commit point. And everything that happens before the commit point is going to be committed to the state. It's because of the actor model. So when actually we are calling this canister, it's a new message. And so it's a new message. And so this previous message is actually committed to the state. So if we do something like this, so this one is going to be committed, but not this one because we don't have an await. So I can show you, we should get 1 in this case, not 2. And so that's like kind of advanced concept, but it's really important to understand that, especially for security, it's a big issue. And that like you can fall into a trap. And when I say trap, I don't mean the trap. I mean, you can fall into a mistake of forgetting about this commit points. And that can leave room for like problems, I would say. So this time we get 1, even though we have added 2. But this one is committed because we have a commit point. But then this is not committed because we are trapping. So if you want to read more about the commit points, I think there is a good resource. Commit points. So ICP, internetcomputer.org is yes, it's not super easy to read, but so yeah, basically, whenever, oops, sorry, atomic method. So this is an atomic method. This is non-atomic because we are awaiting, and every time we await, this introduces a new message, and so we are not atomic. So I hope it's clear. Maybe we'll get some questions on that. It's from my experience, that's like one of the main security issues I've seen in projects. So I haven't done any like professional auditing, and I'm not qualified to do any, but I had some people asking me to review codes, and so essentially that's always the same. I always see these problems with this await. You're not considering that the state could be rolled back or not. And so, for example, like one famous example would be you increment, like you increment a balance, then you do a transaction, so you await. So you actually change the balance, and no, that's not a good example. That would be another kind of issue. Yeah, okay, so I don't have an example that comes to mind right now, but that's essentially, yeah, a big like not an issue because it's, you can get around that, but just something to take in mind, to have in mind. And so yeah. So that brings me back to the second topic of today. So the first one was intercanister call. We've been quite deep into it. Now I want to talk about memory. So actually, I don't need the 2 other canisters, so I will just remove them. Now we just need the counter. Okay. So I will show you that essentially when we deploy a canister, we lose the value of the counters. You probably already know that because you are almost all of you level 2 or 3, so you've already seen that. But yeah, basically we increment, you get 1. But if we redeploy, we lose our state, and the value will be reset to the initial value, which is 0 in this case. Zero. So how do we solve that? It's very easy to solve for like some types. So for example, for NAT, it's super easy to solve. You just do that stable. And so now you have a stable variable, and a stable variable is not reset upon upgrades. So it's always kept. Actually, next time I will make this a query so that it's a bit faster. So that's 1. Yeah, I'm making a breaking change because I'm moving this from an update to a query. But that's fine. And now it should be still 1. Oh. Actually, that makes sense because it was not a stable variable before I upgraded. So now it should be a stable variable. So now it's 1. And so if we redeploy again, this time it should work. Okay, yeah, 1 this time. So this is how you keep the value. Like if you want to keep the value of a NAT, you can also have text that are stable. So you just have to add this stable keyword in front of any variable, and that solves your problem. And so actually I have an entire chapter about this, which is the chapter 12, I believe. Yep, upgrading a canister. So essentially, this stable keyword comes from the fact that the canister has access to 2 types of memories for a lot of reasons, but essentially there is a heap and there is a stable memory. The heap is limited to 4 gigabytes because under the hood, it's using a runtime of WASM, which is on 32-bit addressing, so it's limited to 4 gigabytes. It will be increased at some point to WASM 64, and this will largely increase the size of the heap of the canister, but right now, the heap of any canister is limited to 4 gigabytes. On the other hand, we have the stable memory. So think about the heap as like RAM and the stable memory as SSD. And so the stable memory is like, it's actually not updated here because we are now at almost 100 gigabytes of storage in stable memory. And the stable memory, everything survives upgrades, contrary to the heap. The heap is reset upon upgrades. So by default, any variable that we declare is going to be on the heap, except if we add the stable keyboard, this is going to be on the stable memory. And so stable variables are on the heap. But the bad thing is that there are only some types that can be declared stable. Like the shared, we had some issues with some types, like the hash map. The stable is the same. Not all variables can be declared as stable. So it would be super cool if I could do like, you know, members, let's members is a hash map, dot hash map with like nuts and I don't know, texts. So, oops. Actually, let's use principal. Yep. That would be super cool if we could do this. Like that would make my life and our life easier. But via members is declared stable, but as non-stable type. Why? Because it's a class. And so an object that contains methods, higher class, cannot be stable. So hash map, tree map cannot be stable, which is a bit of an issue. But so there are 2 workarounds that. The first is to get a bit like deeper into the ecosystem. And there are really good people, really smart people that have been working on like stable packages from Motoko. So you can use those packages, you can import them. For example, there is a stable buffer, there is a stable map. That not part of like the core of the Motoko language, but it's a community resource. And so actually it's getting very, very solid. Like a few months ago, I wouldn't have necessarily recommended it because it was still like early days. But now I think most of those libraries, they have been tested, they have been like benchmarked. So actually they are really good. And so we don't need for the bootcamp, but if you want to go a bit deeper with Motoko, I'd strongly recommend to take a look at MOPS. So MOPS, we are using it for the testing framework, but actually there is way more than just testing. You also have like packages like map, which is stable hash map. Vector, it's a replacement for buffer, apparently more efficient. So like it's basically the community coming together and writing cool packages and stuff for Motoko. So definitely check it out. So that's the first workaround, is to use a stable structure from the community, from a package. And I hope that it will be integrated in the language like soon, but right now it's not. The second workaround would be to actually use a stable data structure like an array. So an array can be stable. And we would use something like this. So, yep, we need to remove that. And there are two functions that are called system func, pre-upgrade, and system func post-upgrade. So those are hooks, and as the name suggests, it's going to execute before the upgrade and after the upgrade. The idea is to put all the data in our hash map into a stable structure like an array, and then upgrade, and then put it back in the hash map once we have finished the upgrades. So you could do that. For example, we could do members entries. We would need to define that as a variable. So member entries would be iter to array of members.entries. And so we put everything in the array, and then once we are done, we put, we iterate over the array. So this is a for loop in Motoko. We have our array, which is, no, it's not this one actually. Oh no, it's this. So for any entry in the members.entries, so the array dot values, so this is an iterator. We iterate over all the values, and we put that into the hash map. So it's not super clean. Like some people, I mean, it's not super clean, honestly. Like, I think we are moving more and more towards the stable structures. It's like safer. The problem with those kinds of like techniques, so that's something I would use like 1 year ago when the language was not very mature. The problem is like, what if you forget to add some values? What if you trap? Like if you trap in the pre-upgrade, you're basically completely stuck. If you trap in the pre-upgrade for some reason, if you go above like your array, essentially you would never be able to get back your canister because you have a pre-upgrade, so you cannot even upgrade your code. So like if you push a code that traps on the pre-upgrade, and I can actually do it, that will be like a dead canister. So yeah, would be like this. So of course, right now in our pre-upgrade, because this is the previous version of our code, we don't have any pre-upgrade. So right now it's going to install, no problem. And now in the canister that is live, we have those functions. So this is now the code that is live, is this one. And if we try to, maybe I remove this function, you will see that we cannot upgrade our canister. And so, yes, I want to upgrade. Canister trap explicitly assertion failed at this line. And so now you cannot even change the code because you cannot even upgrade. So your canister is essentially dead. And there is no way to get it back. And so, yeah, definitely, if you can use a stable structure, I recommend it over the pre-upgrade and post-upgrades methods. Any question on the memory of the canister and what we've done? The question is, can I have multiple replica of the canisters, so of one of my canister? So yes, but you can, but you will have to pay for it. So that's the first concern. And the second concern is you will need to keep the states in sync between those canisters. So it's really hard to do in practice. If you have a live application, you have one canister and that's it. Like if your user pay through it, otherwise you would need to, every time there is an update call from one user, you need to make it as well, like to another canister. So that's gonna be hard. And there is no native way from like the protocol itself to just replicate canisters simply. So you would need to implement it yourself, and that's like a bit annoying. What is possible and what is being worked on, I think it's coming soon, the ability to extract the WASM memory from the canister. So you can have, as a developer, you can have like a backup kind of. And even in the case of your canister like being dead, like we did, you would still be able to download the states and re-upload the new canister. And we have a question in the chat. So can we add warnings before the canister fail? What do you mean before, like warnings? What kind of warning? You mean here?
I think what I'm trying to say is like something that allows you to modify the canister before.
An error message and the ability to not continue for the canister to die. Well, I was saying that, I mean, if you know that you're going to have an error, then you can prevent it. But I mean, this case is, okay, of course, we are doing assert faults, so you would not do it in any real scenario. But a trap can happen if you go, like, for example, a typical example would be dividing by 0, or like going outside of an array. You just try to look an index that is above the size of the array, you would trap, and you cannot really know it. And once you trap, there is no way to warn you in advance as a developer. So you essentially don't have the ability to warn anyone.
That doesn't it's more clean, not an error failure. Like this has failed, so why?
So try catch, for example. Okay, so try catch in Motoko are very, very special because they are not like in other languages. So this is because, so try catch in Motoko are only used to call other canisters. Let's take a look at it. So try, actually, I think there is a chapter on it, I believe. Chapter 13, maybe? No. 10. Yes. So this is about like errors. So there are 3 types, I would say, of errors in Motoko. There is the result type, which is like, I would say, the good errors, because those are the ones you can handle and they are like part of the runtime, normal runtime. So this is good. Then there are the traps, which is like the errors that cannot be resolved. So basically your canister just stop the execution of the function and get out of the runtime. So division by 0, index out of bounds, and assertion failed, false. You can do a debug the trap, so that at least gives you a message that you receive when you trap, but it doesn't prevent the trap. So this is the last type of error, is the one that we would have with the error library. And so you can throw an error like this. So you throw an error. Wait. How did I explain that? It's actually fun because it's reading myself like from a few months ago. How did I explain this? So in Motoko, error handling can be a bit confusing, especially if you are used to error handling in other programming languages. Errors can be thrown using the throw keywords. Errors can be handled using the try catch. An error is of type error, so there is actually an error like library. This is not what I wanted, this one. So it's an error library. So you can use that. Or if error handling in Motoko can only be done in asynchronous context. So what it means is that you can only throw or catch in the body of a shared function. So in this example, we define an actor that contains two functions, throw error synchronous and throw error asynchronous. So this will not work. This is not possible in a synchronous context. So in the execution of the canister itself, what you can do is return an error for another canister or user. So like if you throw, when you do an intercanister call, the other canister can do a try catch. And so it can know that there was an error, but you cannot use try catch in the pre-upgrade, for example, because you are only working within your canister. And any private function or any function internal to the canister, to the actor, you can't use a try catch. It's only for asynchronous context. So there is an example here. This is you have canister A that has a public function foo, canister B that is going to consume this function. So try catch, try let foo is equal await canister A dot foo, and then you return foo if the execution is correct. And if there is an error, so an error could be maybe the canister is out of cycles, maybe the canister trapped, maybe the canister thrown error, actually. So any type of system kind of error, you will be able to catch it and handle it properly. But this is only for asynchronous calls. Yeah.
It's expected you go through your code working for.
Yeah, it's it's a limitation because of the actor model, but it's not specific to Motoko. In this case, it's very specific to the IC. Maybe. Oh, okay. No, we are on time. I don't know. Is there any more question? Yes, you can pass environment variable to a canister. So I think actually it was added a few months ago. So I'm not actually environment. I think the best is to look on the forum. And yeah, I actually haven't used it. So there was Motoko. So I know what could be done is when you do I have an example of that? So when you create for example, this is a good example. This is my dashboard. There is an environment variable which only is only going to be sent, initialized when you deploy the canister. So for example, here, I'm using this in the construction of my canister. It will give me basically the ID of the person that deployed the canister. So this is a variable that I can use, of course, in the case of my admin. So I have an admin module that I use. And so I need a master admin. And so this is going to be the person that deployed the canister in that case. So this is how you could pass. And you could actually pass arguments inside. So like you could pass, I don't know, like initial students with type students. I mean, this is not going to work because we will need to define students before, but maybe like initial students name of text. You would use that and you would be able to pass it as an argument when you deploy. So when you do the fx deploy, you will need to provide an argument, and this would be initialized like this. So you can do that, and that's been the case for a long time. But I believe now there are new ways to do it. Actually, I'm not like mock as a package. So yeah, there are some updates on this topic. Yeah, so I think the best is to read this. I don't want to say anything that is not correct. So it's in the chat. Okay. So next session is in actually 10 minutes. I have a speaker coming. It's a really cool application. Actually, it's called Juno. So this is not the one. Juno.build, which is like a Firebase for ICP. So you can create application, like you can deploy any kind of front end or like Svelte, Vue. And you can also add like databases and more. And I think it's going to be a workshop from what I understand. So I'm not 100% sure, but so David, the creator, okay, I cannot log in. So you will see later, but he told me that it would be a workshop. So I don't know exactly what's going to happen, but yeah, maybe we have a workshop. I see you there in 5 minutes. And yeah, goodbye.